Okay, so this is a quick look at exercise 5H, which is on functions and modeling. So this is applying a functions notation, domain and range to actual modeling situations or real life situations. So this is two quick examples to look at. Most of the time, the equations might be a bit simpler. If the equations are really quite advanced, that would be more something you would expect on the end of semester exam where you're allowed to use your calculator. Okay, if the numbers are real complex or involving lots of decimals or really hard fractions, then that will be on the calculator allowed. Otherwise, these ones are going to be a bit more simple. So this is two cases, and both these examples are involve linear functions. So as a quick reminder, linear functions, we have y equals mx plus c, where our m is our gradient and our c value is our y-intercept. Okay, so I know we haven't dealt a lot with linear functions in this class. We've been more complex than that, but that's what most of these examples are going to use. So example 1, the book club has a membership fee of $60 and each book purchase is $10. Construct a cost function that can be used to determine the cost of different numbers of books, then sketch the graph. So let's start with an equation, something quite simple, and we'll build it into a function. So we start with y equals, and in this case, our initial cost is $60, so we get y equals 60, okay? And then for every book purchase, cost another 10. So we'll go plus 10, and we'll call it x is the number of books purchased. If you hear little tippy tappies, that's my dog walking around. Okay, this is an equation. We can plot it quite straight away, but we want to build a function. Let's use some variables that are more appropriate. So how about we go let c equal cost of membership, okay, in total, and we'll let n equal number of books purchased. Okay. Since in this whole problem, we aren't given any variables. Okay. Since we're given no variables, we need to define our own. You can't just start with y equals 60 plus 10x and go, yeah, done. Okay, what's y, what's x? You haven't defined that, so I could pick anything and tell you your formula, your equation here is wrong. So let's define some variables. So then we get a function c, a cost, because that's what we want to make, is a cost function. C of n is equal to 60 plus 10n. Okay. Or if we want to put it in a more common gradient form or linear equation form, we get 10n plus 60. That's a basic cost function. If you want to go full out, if you want to go full function notation, okay, what would that look like? Well, we've got a function, okay, our domain. Now this is a little tricky. Most of the time our domain we can just say it's real. Well, in this case, yeah, it could be real. But can we purchase 1.3 books? Okay. No, we can't. We can only purchase whole numbers. So that's integers. Even then, can we purchase -3 books? Okay. We can't. We can't purchase 1.3 books. We can't purchase -3 books. So the only thing we can purchase is positive whole numbers or no books. We can either get 0, 1, 2, 3, 4, so on and so forth. Okay, so that is natural numbers. Okay, so we can have natural numbers or so union with 0. Codomain in this case, okay, because our equation, our formula has no decimals in it, and we're only putting, we're going to have natural numbers again, and then we get cost of n is equal to 10n plus 60. So if you want to build full function, it would look like that. Most of the time, this is fine for purpose though. Either one. This is fine for purpose because it's all assumed. So it says sketch its graph. Now we just said we can't purchase 1.5 books, or 2.5 books, or 3.5 books. Okay, so 1, 2, 3, 4, 5, 6. And if we have no books, well, it's $60. One book is 70, 80, 90. 4 books is 100. 5 books is $110. Technically, because we can only buy 1 book, 2 books, 3 books, this is how we should plot a function. Technically, okay? Because I can't buy half a book or 1.75 books. Okay? But for convenience sake, we don't leave it as individual set points. We mark it as a line, okay, as a continuous function. Now we know, and I keep saying it, we know that that's not the case, but again, for convenience, just like leaving it in this form, we just draw it as a continuous function. So that's the first one. Pretty straightforward. Second one, Mr. St. Pierre, so myself, and this is based on a true situation. I went to Queensland near the end of last year to go to a friend's wedding, and being up in Queensland and being in a more remote location, we had to hire a car. And we had to choose between 2 companies, and most of their models are like this. Some have a fixed rate per day, which in this case we'll say budget hire does, and then we'll say Avis has a cheaper per day rate, but you also have to pay however many kilometers you drive on the car. Okay, so our example, Mr. St. Pierre has to hire a car while in Queensland for a friend's wedding. He has 2 options, rental with 2 different cost methods, Avis and budget hire. As per that, create cost functions C1 and C2 for the 2 hire company rates, where C is the cost per day. Okay, so C isn't the total cost. Okay, it's not saying if I hired it for 5 days, it's not the budget, it's not C equals 89 times X. Okay, that would be total cost. This is C is the cost per day. Let's do that, and we'll call Avis C1 and we'll call budget C2. So we've been given these 2, so we don't need to define them. Just over here will be fine. But we do have to define our independent variable that ends up determining this cost, and it's C is the cost per day. So what is the independent variable? What is the thing that's changing? Well, it is the kilometers traveled. So let's let X equals average. Okay? This is a big thing, average, because we want to average out over the whole trip. Average number of kilometers traveled. Okay. Cool. So let's build C1. Okay. C1 of X is equal to, well, 34, no matter what, for the day, plus, and that's in dollars, okay, 0.5 times X. Okay. That's going to be the cost per day, where X is the number of average kilometers. Now, what about budget? Well, budget is just a flat rate of $89, so C2 of X is equal to 89. Now, here's the interesting thing, and this leads us into this question. Does C2 actually have an independent variable? By that, is there something I'm putting into my function, okay, some number that can change, any type of variable, that will then impact the outcome? And even though I've put C2 of X here, okay, we don't need that, okay, because the answer to this is no. We have no independent variable. Doesn't matter how many kilometers I travel. I could travel 1 kilometer, I could travel 1,000 kilometers per day. It doesn't change my C2 value, my cost per day to hire through budget. So no, there is no independent variable. Now, well, that's all well and good. We've made some functions. What use is it? Well, how about we compare the 2 and figure out what might be cheaper depending on the situation. So let's plot C1 and C2. So we said C1 is equal to 34 plus 0.5x, and C2 is equal to 89. Okay, so let's go X there, and this is going to be a C value, and I might make, just to be clear, that blue, and this is going to be in dollars. Okay, and this is X is kilometers. Okay. So let's start with C2. C2 is nice and easy. C2 is equal to 89, and it doesn't change. Doesn't matter if I travel 20, 40, 60, 80, 100, doesn't matter. I'm going to let this 20, 40. We'll do that. Okay, so 89, well, 9 is there, so we can go a smidge down. And of course you'd do this with a ruler, but I don't have a ruler in this system. Okay. That's terrible, I apologize, but close enough is good enough. Oh no, and then it's gone and deleted itself. That's better anyway. So this is C2 equals 89, and our intercept point is 0, 89. We always want to put that in. Let's do C1 again. Okay. We have a linear function y equals mx plus c, or in this case we have 0.5x plus 34. So our y-intercept is 34, so where's 30? 30's there, we'll say 34 there. So we've got 0, 34, okay. And what we can do, we can just substitute in a whole bunch of values to get some points. So let's do that. Let's start with C1 of 20 is equal to 0.5 by 20 plus 34 gives us 44. Let's maybe put in C1 of 80 is equal to 0.5 by 80 plus 34 is going to give us 40. That's going to give us 74. Let's go C1 of 100 is equal to 0.5. 100 plus 34 is equal to half of 100 is 50 plus 34 is 84. Okay, so this was 89. So let's plot some points, and we know we could have picked a, because it's a linear function, we could have picked just subbed in 140, got our point, and then drawn our connection. Because it's linear, it's going to be a straight line. So 20 gave us 44, which is about there. 80 gave us 74, about there. So we're starting to see, yeah, that's a straight line. 100 gave us 84, and this was 89, so 84 is going to be about here. So even if I traveled 100 kilometers per day, okay, my cost per day is going to work out cheaper going with C1. Which company was that? That was Avis. Let's draw that in there. Okay. So we clearly have this intersection point. Okay. And after this intersection point, up this way, Avis is more expensive. Okay. So if I'm traveling less than what this is, and this is estimated showing between 100 and 120 Ks, somewhere in here, okay, if I drive less than that on average per day, Avis is going to be cheaper. More than that, Avis will be more expensive. And guess what? Question C, how many kilometers per day does Mr. St. Pierre need to drive for it to be cheaper to hire a car from budget than Avis? Well, we want intersection point to know that. So when our two equations are equal, so we're going to let C1 equal to C2. So it follows on that we have 89 is equal to 34 plus 0.5x. And we can make an estimate, and we know straight away, well, it's got to be a little bit more than 100, might even be 110. Let's see what happens. So we get, take away 34 gives me 55 equals 0.5x. So we get x is equal to 55 divided by 0.5, which happens to be 110 kilometers. So that intersection point there is 110.89. And this is a worded question, so we have to have a worded answer. Okay, so Mr. St. Pierre must drive more than 110 kilometers per day for it to be cheaper to drive or higher from budget. So that's the extent of exercise 5H. Okay? Is taking a worded situation, identifying your independent variable, dependent variable, and forming a function. Big thing with this is, and I'm going to go back to here. Okay. Big thing with this is this. Okay. If you aren't given variables, letters to define them, you must define them yourself. Okay? And then form your function like this over here. Okay? You just can't assume and always using y equals something of x. Okay, don't always use y of x in this. It's much better, okay, and better standard, especially for future years, is to get in this form of using relevant letters as variables. If you have any questions, please let me know. Stick them up on Google Classroom. Thank you very much.